My name is Ryan Booz. I work for Redgate Software. Redgate's actually based in Cambridge, England, and I'm happen to be at the headquarters this week. And so we Redgate's been around for 25 years and does lots of things related to database that we call database DevOps. And that's primarily has been a SQL Server shop for a long time, and has been branching out into other databases, including Postgres. And that's the main reason I'm here, because they're trying to do Postgres stuff, and it's been fun to work with the team. So I realized, like, I don't know how much time we really had, so I actually have like a 45-minute, this is everything I love about database DevOps and use Flyway thing presentation. What I will do is put a link to that maybe in the chat after I give my little piece, so you can, if you want to go watch that from a Flyway perspective. But that talk, and that's where I'd love to hear from the other tools. I've used David's tool in previous companies and really appreciate Sketch. Just the concepts of what you want in a database migration tool. So I guess I'm hoping maybe after we all talk about our things, like that's one or two of the questions we'll address together, because they're all being approached similarly and yet different, and just why those things are. So I'm not going to get into that right now. I just want to talk briefly about Flyway community, what it is, what you can do with it, what it provides, and go from there. So oops, there I am. Great. Flyway. Oh, sorry. I'll put that up there for 1 second. This is how you can contact me if you've never seen me talk anywhere. I am still active on X. I do actually have Blue Sky now. I need to get that on here. I'm starting to blog again, and yeah, reach out. I love to connect with folks. And if you have questions on anything I talk about today or anything else we do, let me know. So Flyway community. So Flyway itself has been around for, oh goodness, probably about 13 years as a Java-based tool. So it was an open source project written in Java with the sole intent of being simply a migration-based tool. All right, so I have scripts that I want to run in a specific order to continually migrate the state of my schema and the state of my database over time. Very popular open source tool, and we actually know, so Redgate acquired Flyway in 2019. And Flyway community is still based in the open source project. So there is still a GitHub repo that is Flyway. That is the open source version, and we still provide that. We provide it as a community version because we've added some tooling on top of it in desktop, which I'll show you in just a little bit. But it is, yeah, it's free to use, will always be free to use, and things like that. And then obviously we have taken Flyway and added other stuff onto it in paid versions. So, and that goes to our history. Our history is one that we've done a lot with migrations and SQL Server over time, schema compare stuff, all those kinds of things. And so we've added that stuff into the paid versions of Flyway. And then there is a free cross-platform desktop client, which, again, in the Postgres space, I guess this is what I've seen is, longtime Postgres users, generally Linux-based. A lot of folks are comfortable with command line, and everyone loves command line tools, and that's just how they're going to work. And obviously, when you get to CI/CD, using command line tools. Over my career, as I try and continue to teach folks, teams I work with about schema management, database migration management, things like that, a lot of them not well versed in databases to begin with. So some of it's an educational thing. And so I've really, one of the things I longed for, having come from that SQL Server space into Postgres, I had those desktop tools I could, had a common way and to teach and learn and show my teams. And I feel like having this available now is just, it's really helpful. So I'll show you that in a little bit. Flyway in the open source community version supports generally 7 what we call verbs. So these are actions you can take against your database that do something, right? So the predominant thing that everyone knows, that thinks about, is probably caring about, is migrate. I have a database at some specific state. I add a new script that's going to do something to the database, and I want to migrate from version 3 to version 4, and whatever that script is. And I can have many different scripts. People approach this differently. Some people, every small change is a version script because they want to have that specific control. Other folks, batch up a bunch of stuff together. And then there are different kinds of scripts you can run, which I'll get to in just a second. We have the concept of baselining. So if you have an existing database, you can baseline that database, which basically says, hey, this is the state of the database now. Don't touch any of that stuff. And we're just going from this point forward. And basically, we initiate the database to understand when that starts, and then you can move from that point forward. Clean the database. If you're working in like a dev or a staging database and you just want to start fresh every time, you can clean the database just to make sure all of your migration scripts run, which is a great way to check that it actually, you haven't messed something up along the way. Validation, info, repairs, mostly useful for baselining and a couple other things. If you get something gets out of sync, you can repair the tracking table that tracks all those version scripts and so forth. And then we have the desktop client. So it's cross-platform, works on, I think there's Linux version. It's been a long time since I've looked, and I should have just looked at that. We're having discussions on something else, but definitely Windows. We certainly have, iOS, Mac OS, and then Linux. And the thing that I love about the desktop client from a learning Flyway perspective, maybe in a weird way, it's almost like, doing pSQL with echo hidden off or on, is you can kind of generate the commands that, with all the potential properties and parameters you can add in, rather than having to kind of figure it out and test on your own. So you can kind of build them there, either run them from the client, or maybe you copy them into scripts you're doing and running from. And then the client also has built-in, fairly simple, but a good built-in Git integration. So you can do a diff against the scripts. The migration script you have, you can see the state of your database, whatever target you're looking at and so forth. So that's pretty cool. And then paid versions, like I said, there's more that the desktop client can do. It can actually help you generate migration scripts, save copies of your whole schema, so you can see how your schema itself has migrated over time and so forth. And then the deployment scripts, and I think this is where, again, each of these tools approaches some of this stuff differently. We have version scripts, so that is generally what you would consider migrations, right? So we have a V1 script. This is the state of the database at this point in time, and then we make some changes, maybe call that V2. There is some nuance. You can change some of that naming depending on how you want to name the files. But generally, it's something that's done sequentially, and so it can be a timestamp, it can be version names. It's just a naming scheme that you choose, or there's a default one out of the box, so that they're run in the right order. And then we also have repeatable scripts, which would be, I always use them for idempotent things, right? I need to keep static data in a table. My list of states, and I don't know, I shouldn't go there with the US. Anyway, whatever that is, list of products, and I need to add a new product over time, but that is a static set of data that's relational to another table. And so usually they're written in an idempotent way so that they can be run without affecting old data, but adding new. So in Postgres, that might be a insert for update, insert on conflict update, something like that. And they are only run when the script itself has been modified. So there's a checksum done on the script. And so every time a migration happens, it looks to see if the checksum of the repeatable scripts has changed. And if it has, the assumption is that script has to be run against the target database. And then we also have hook-based scripts. So Flyway community has a number of hooks. An example would be before migrate or after migrate. And there's a bunch of others. You can write a script literally called before migrate, and that script will run before your version scripts and before the migration actually happens. There's a number of those hooks. And then any of these scripts can be written in SQL. I am not well versed. There is still a way to do the version scripts in a Java format that is interpreted within the original Flyway tool. I'm not an expert. I don't even use it, so please don't ask, because I don't know many people that do. And then any supported language. So you can write like a before migrate script in Python. And as long as you have the runtime on the computer that you're running migrate from, it will find that Python script that's supposed to be run before migrate. It's literally named the same thing, and it will run that script. So you have a lot of control over how you use the versioning and work with Flyway. And then from a script deployment features within particularly SQL scripts, we do have a number of features. One is placeholders. So you could, you can put into the command line environment variables that are filled in when Flyway goes to run a script. It will look at the script and say, hey, do I see a placeholder for maybe it's username, right? So maybe it's a connection string, and each database has a different user, a role that you're connecting as, and you need to change that in some way. So that could be one example. Deployment features, you can also specify that some scripts are only run in specific environments. So you can set an environments up for Flyway, a dev environment, staging environment, production environment, and say, hey, this script is only to be run in production. And so as long as you're using environments, you can control deployments of scripts in that way as well. And then finally, there's some neat things. I just added in SQL on because this literally came up on Monday. I think it was Monday, or maybe it was last Friday. There was a discussion on the Postgres Slack. Jeremy Schneider had asked a question for his company about roles and permissions, which is, I love roles and permissions, and it's a huge, topic of just how to understand it well, particularly when it comes to migrations, object ownership, all of those things. So he was asking about, hey, how do we do this? And I was like, oh, you know what? I have this blog post and it talks about how to set up a template for permissions and set, maybe set role before you run the script, and where do you put that? We went back and forth. And I was like, I totally forgot about the init SQL parameter. And so this is a really great way to say, hey, every time I run a migration in a Postgres database, I generally want, my opinion is, all of the objects to be owned by the same role, so that that role can set up default privileges and you can manage your object, privileges and so forth in the correct way. Well, how do you do that? Well, you make sure that before that script is run, you first say set role and whatever the role is, so that the context of that session is in the role that you want all the objects to be created as. And so that was the discussion we had and came out with that. So that's super quick, high level, just what Flyway is and what we do. I will say we have a built, and I'll put some of these links in the chat. We have been building this thing called Autopilot. Now it's intended to look at all the features, including the paid features, but there are portions of it that are just helpful even to get to know Flyway itself. And so we call it Flyway Autopilot. There's a Postgres version. I'll show you the screen here in a second in GitHub. And, probably the most intriguing part of this is ultimately for us, for me, this is all about getting into continuous integration and deployment. And so we provide a number of examples for GitHub and Azure DevOps, YAML files for actually doing various deployments using Flyway. It doesn't matter how the scripts are generated. Yes, there's a lot about it that's intended to show you the paid features, but the scripts themselves, it's just Flyway. And so you can use those as examples to test and see how that might work within your environment as well. And really the whole goal from our perspective, my perspective has been over many years, I want my dev changes to be able to, as seamlessly as possible, get from where I started into production with the right amount of checks and so forth in place. So super high level. I want to really quickly, with 60 seconds or less, show you Flyway Desktop, and I have lots of windows from Zoom covering me over on this thing. But this is Flyway Desktop. It is available for free when you download Flyway Community. If you want a desktop client, it is there. This includes Flyway, the CLI. You can install that separately, just on its own. So you don't have to have desktop, but if you install desktop, you get Flyway CLI as well. And in the open source, so in the community version, you will only have the migration scripts tab. But what that does is give you a window into the table within whatever target you are looking at. If you say, hey, my target is production, it will refresh and show me, here are the scripts in my project, and here is the state of the scripts. Now I just restarted this Docker. Okay, it is working. So it'll show you the state of the scripts, and I can see I have one pending script. So if I were to then run the migrate command, it would be running that one script. And again, maybe a repeatable script if it had changed, things like that. So lots of ways to use this. And then, as I said, there is built-in version control. So if you want to version control your migration scripts, you can do that right from in here. You can branch and do all this stuff here. So, all right, so that's super high level. And I will now turn it over to, I guess, David?
Yeah.
Yeah, 1 second.
And, I'm just in the interest of kind of managing time. Maybe if people have questions about kind of what Ryan was talking about, we can just offload those to the side chat, and then kind of continue on with David's part. Thanks, David.
Yep, I think it's great.
All right. Let me know if you cannot see my slides. All right.
Yes, we can.
So my name is David Wheeler. I work at Tembo, but back in 2012, I was working for a company called Ivation, and we needed a database change management system. And I had written a number of shell scripts working for PostgreSQL experts for years before that. I was like, let's just solve this problem properly. I don't think Flyway was even around then, or maybe it was just getting started. The existing stuff were like Rails migrations, and there was something that was just like XML scripting and stuff like that. I'm like, I'm a Postgres user. I want to use PSQL. And so I built a thing. So back in 2011, 2012, I had some pretty strong opinions on what was wrong with the whole idea of database migrations. Most of them provided an incomplete mini language. So when I used Rails migrations, I was always dropping down to the pure SQL thing and using that. They had no logical replication integration. The numbered scripts I found very difficult to keep track of. And there was no VCS awareness. Obviously, a lot of that has changed in the interim. So, but what I wanted to talk about was a change like this. Let's imagine that you realize that your old way of managing passwords using MD5 is not working anymore, and really you need to switch to using proper cryptographic hashing functions. So you're going to make a change like this to your function that sets a password. So seems simple, right? But not so much. If you're managing your scripts yourself, the first thing you have to do is paste the entire function to a brand new up script, and then edit the new file, and then copy the function to a new down script, and you have 3 copies of the function. And there's no real source code management. And when you commit all these, you can't tell in the change what changed, because it's just like 3 brand new files for it. So it's difficult to track what changed. So this was one of the motivations behind Skitch. Skitch's philosophy is for native scripting. If you're using Postgres, you write your change scripts in PSQL. If you're using SQLite, you write them in SQLite 3 scripts. If you're using Oracle, use SQL+'s integrated scripting stuff. So it's very much intended for people who are comfortable with and like to use the command line interfaces for the database they're familiar with. I wanted to reduce the duplication, as in that example I just showed. I wanted to have kind of an iterative development process, so I could be making changes and deploying changes and averting changes over and over again as I do my development process. I wanted to have a Git style command line interface and a hierarchical configuration, also similar to Git, and the ability to do deployment. So today, Skitch supports a whole bunch of database engines. The main Postgres variants plus SQLite, MySQL, MariaDB, Firebird, Exasol, Oracle, Snowflake, and Vertica. Adding new engines is actually kind of a pain in the butt. I think I have done most of the work for most of these. There's been like a pull request for SQL Server for like 10 years. But once they're locked down and locked in, they work very well. So I want to give a quick demo here. Hopefully you can see my terminal.
Yeah,
Yes.
looks good.
Yes, we can.
Great. So what's the layout of a Skitch project? It looks like this. We have a configuration file, a plan file, and directories for deployments, reverts, and verify scripts. So let's look at the configuration. This is a configuration for a project that's using the Postgres engine. The main user is Marge Overa here. There's a named target here, flip a test with the URI. You can have configuration settings or variable settings for like PSQL variables or Oracle variables as parts of these targets. So you can define different targets to have different behaviors. And the deploy and release bits there are just that I want the verify scripts to run. These are things that verify that the script ran properly and exit with an error if they didn't. So they run by default when you deploy or rebase. So let's update the config. I'm just going to set it for myself here. So now it's no longer Marge, but now it's me who's using it. So let's take a look at what's in the plan. This is the plan file. It has a couple of declarations up here for it. The URI for the project is here. And each line is a single change. This name, name of this change is app schema, in which it creates a schema. This one is users, in which it creates users, et cetera, et cetera. Inserting user, changing the password. This line here that starts with an @ is a tag. You can tag a particular point in the plan, and that's generally done for releases. So I would release this as the V1 Dev1 release, and then there are other changes after that on down. So the deploy scripts are just SQL scripts in the deploy directory, and you can see each one has a name that is equal to the name that it had in the plan file. And the contents, as I said, are just plain old PSQL file. It just does all the things, normal things in a PSQL file. One thing I'm periodically asked is like, oh, can you like wrap each of the change scripts in a transaction? And the answer was no. I wanted the user to have control over that, in large part because many databases do not have transactional DDLs. So there was no point in wrapping a transaction. And even Postgres has a couple of non-transactional changes you might want to make. So it's leaving that control here. So you can see it's very focused on providing all the capability and flexibility that somebody who's familiar with the database engine likes and can take advantage of. Revert scripts, exactly the same file names, just in the revert directory, and their contents are really just the revert. So this allows you to, the terminology of a lot of these systems to migrate or migrate up and down, Skitch calls this deploy and revert. So let's deploy the changes. I'm gonna have to start over now. Right. So let's deploy the changes. I created a database that the name for the target, as I had the flipper test target configured in the configuration file. And I just execute the deploy command and tell it to deploy to the flipper test target. So it actually creates the registry tables there and deploys the changes in order in the plan. You can see tags show up here as well. And there are plus signs here to show that they were deployed. So what's the status? The status command shows you the status within this target. And you can see here that the current change has this SHA-1 hash and its name and when it was deployed and by. Similarly, there's a log. You can run Skitch log and it'll show you the activity on the database in the reverse order in which they have, very much like a Git log here. So you can see each one of these changes was deployed with their SHA hashes here. So let's rework a couple of changes. The rework command allows me to make changes to scripts. I believe these are idempotent things like create a replace function. So I'm going to make the change here to the change pass and insert user changes because to make that change for password hashing I showed earlier. So I'm just going to fix these. You can pretend I just edited those files. So this is what the change looks like now. So you can see that I've changed the deploy change password to use the new hashing. And same with insert user is now using the new hashing as well. You can also see that the revert change has been changed to what was previously the deploy change for this change for change pass and insert user. And normally I go in and I would like edit this to change the revert, but you get the idea. And you can see that the two new changes have been inserted at the end of the plan file. The stuff that appears in brackets, these are dependencies. So this is saying this change depends on the previous insert user change as of this particular tag. So you have to have a tag before you can rework your changes. So I'm going to deploy that. You can see the two new scripts have deployed, and we can see the results. If I take a look at the database, you can see now it's using the new hashing. And if I revert, I'm going back to the PG crypto change, which was just before those two changes. Skitch likes to use a little minus sign to show that these changes were reverted. And if I look again, we can see we're back to using good old MD5 here for the hashing. Now here's the thing, we can actually tell it to revert all the way back. So this is reverting all the changes back to the very first one. Even though we saw that the revert script was replaced by the old deploy script. So how is that possible? Well, what Sketch does is it actually kind of replicates all that copying that I described earlier for you, and it creates these previous versions to say, okay, this is the deploy change as of this tag, so that when you do a revert, or when you do a deploy from the very beginning, it uses the corrected version of that script as of a particular tag. So I'd end up committing all these and pushing them to the repository as the change. But then you know that like the main changes that we're interested in are in these deploy scripts, and your changes will actually show up as you would expect in your change management system. So that's my little demo. There's a lot more to Sketch. It does release bundling, so you can package it all up for a release to ship out. It does rebase changes. You can make changes to a script and tell it to rebase, and it'll revert and deploy for you in all in one command. Similarly, you can switch between Git branches, and it'll revert to the last common change between the two branches, switch branches, and then deploy for the new changes in the new branch. There's formatting the logs, similar to how Git does stuff. You can do deployment configurations. I was saying you identify the targets, so you can specify variables and other configurations that have to do with each target. It does deployment integrity. So each change, actually those SHA-1 hashes you were seeing before, those are following a similar pattern to Git, and that's using a Merkle tree pattern in which each SHA includes the SHA of the change that comes before it. And that ensures that you get the integrity of the deployment order of your changes. So even though they're all in one line, each on plan, you can have multiple projects and actually create dependencies between projects. And when you do the deployment, it makes sure that they're all deployed in the correct order. And if things get out of whack, it'll let you know. Integrated testing, which I said, those are the verify scripts. Basically, like after you create a table, you just want to make sure you can select from it or something. And if it doesn't, it errors out and you have a problem. It does dependency resolutions. As I said, you can have multiple projects that depend on each other and specific changes in each other. The iterative development process, which I kind of showed you a little bit just now in the demo, that's kind of the way you work with Sketch as you're doing development on the database, and the release tagging process and the what to do stuff. And there's more. This is just what I knocked out of my head yesterday. So that's my quick demo introduction. If you enjoyed it, I'll turn it over to Eugene.
Thank you. Okay. Okay, I think it's visible now, right? The presentation.
Yep.
Okay, I wanted to thank for Elizabeth first to gathering up us all and letting us learn all these similar things from each other. I actually didn't try the other migration tools yet, but I watched the talks before. So I'm happy that we are actually getting this first-hand experience. Thank you, Elizabeth. And me, my name is Gülçin Yıldırım Jelinek. I'm working at Zeta, but I think my most, I don't know, interesting thing about me that I have 3 types of eye. You can see here. This is like the normal eye that everybody knows. This is Turkish eye and this is Czech eye. So I think I'm a good test case, and it's like, I like that about myself. And I'm active in the Postgres community and happy to be here. I wanted to start the day with a proper quote because I think this does a pretty good job of summarizing the problem space. Database schemas are notoriously volatile, extremely concrete, and highly dependent on, and that's why I think these smart tools are important to when you are actually developing stuff and you are changing the schemas all the time and you are running multiple projects at the same time and so on. So I like this quote from Robert C. Martin. He wrote it in Clean Architecture. And I also wanted to go there was this research, I think, about in the reference I will share where was it taken, but the average cost of unplanned downtime was this much of per minute. $14,000 per minute is really a lot, and it seems to be getting higher. Since 2022, there was a 10% increase there. And the reason that I add this here, because if you can't really manage schema migrations, there is a risk attached to it that might actually cause you downtime. And so this is the tool today. I will describe PG role. This is what we built in Zeta. It's like our flagship, I think, between our open source tools, because we have a lot. And you can see it in the GitHub. It has the Apache license. Even though we built it in Zeta, you can contribute to it. And actually, we really like the feedback. And on the last release, which is 0.10, we got already, somebody contributing to it. I mean, we get other contributions too, but it was really good that every release we have somebody reporting something and contributing to it. Makes it really fun to work with. And it is fully open source. We don't have a difference between free features or paid features. There's no paid feature. And it is designed exclusively for Postgres, and it is not adapted from any existing migration project. It only works with Postgres for now, and probably that's how it will be. This has a zero downtime migration policy. The PG role organizes the statements in a way that makes sure that we are minimizing impact on the production systems while we are doing these changes, because this is considering how Postgres is designed. So we work around it, how Postgres log queue works, the locking mechanisms around it. And we have the set log timeout, for example, for each transaction that we run. And we can do batched backfills. So since this is designed directly for Postgres, we know Postgres. So the tool really works based on how basically Postgres works with. And it has a high level management opportunity for migration changes. So we have operations, PG role operations, that is like not directly SQL. And you can write SQL too as migration, but we kind of have convert them to the PG role operations. This allows us to do stuff that we can't directly do with raw SQL. And it is easy to integrate with CI/CD pipelines. Maybe we can do better at explaining them or preparing, playbooks. I've seen that the other presentations mentioned this. I think we can do better there as well. And I think the most distinct feature about PG role is that we allow multiple schema versions to work at the same time. So this allows making testing and blue-green deployments and rollbacks super easy. These are the things that I thought of when I should describe PG role that came to my mind that I think worth mentioning. And what was the motivation behind the tool? Schema changes are difficult. As you know, for alter statements, most of them takes access exclusive lock, which is the most restrictive lock that you can take in Postgres. And we try to minimize this. So we separate the commands in a way that they don't hold on to access exclusive lock as long. And there's also like opportunity to do the backfilling. So let's say if you're adding a column with unique constraints, you'll have to change this data as well. And there are some commands requiring multiple steps, like when you're naming column, for example. And we wanted to have like to avoid issues with backwards incompatibility with different versions of the application. And one thing that is clear, like for everybody who probably work with Postgres, even like simple looking selects can cause an issue, because how Postgres look queue works. Imagine there's a select and it is holding and like is holding a lock that normally wouldn't be considered like very restrictive. These are the minimal level locks. But then alter table, since it holds the access exclusive, when it's trying to require this lock, it conflicts with select, so we can't actually take the lock. And then anything that comes after this will be behind the queue, and that will kind of have this cascading impact on the Postgres. Yeah, it might cause the delays or even downtime. So we recommend normally if you didn't set log time in Postgres, this has to wait forever. And since we know this, we actually have a set log timeout in PG role, and that kind of helps. I think it is 100 milliseconds actually. This example is just like was an example that you can actually change it in Postgres if you want to do. And that's one thing. And there are like other things that we try to do, as we mentioned in the motivation. So yeah, locking behavior can be surprising, and we have to do some different things to achieve zero downtime. Okay, so how does actually it work? And again, since the motivation was clear that there were some design goals, the first thing that was wanted, that we wanted to build a migration tool that has multi-version capabilities. And so for every schema change made with PG role, for example, adding a constraint to a column, PG role exposes two versions of the database schema to client applications. The first version represents the schema without the change, and let's say without the constraint in this example that we are thinking. The second version represents the schema with the change and with the new column constraint, basically. And so PGROL does this, keeping the data in both schema versions in 6. So it's still like work for both of them. An application can choose which version they want to use. And this makes application rollouts much easier. And even old version of an application can run alongside each other. So you don't need to carefully synchronize database and application deployments. And the other main goal for PGRO was that building smart locking behaviors, which I actually mentioned a little bit in the previous slides, to write into the tool itself. So we wanted to make sure the tool is aware of this, and especially when performing DDL changes, we have to be mindful of how long we are taking access exclusive locks, and if we can avoid the time that we are holding it, it's important. So we have this Postgres operator specific knowledge, and the tool is aware of it so that it takes the burden off of application authors. As I said, we allow higher level operations. So for each statement, like instead of like alter statement add column as we do with normal SQL, we have this like add column operation, rename column operation, add index operation, and so on. And we use JSON format to do the backfilling of the data. So we actually modify the data up and down in between the different views. And one thing that is different, maybe unique even for PG role in the migration tooling, we use this automated expand contract pattern, which means that we actually add some columns to the physical table as when we are changing it. We change the data, we backfill it, and we transform them in background. And then once the thing is done, we actually contract the thing. So that's why, like, first you add stuff, that's the expand part of the pattern. And then once everything is over, you are happy with it, you complete the migration, and all the temporary columns are deleted. You don't need to anymore use them, so they are gone. And we achieve this with different schema versions with different views. So the one version is seeing the one schema version connects to a view that has the old version of the schema, and the other one has, let's say, the edit column, the edit check constraint, and so on. So you can actually, at some point, they are all working simultaneously, and once you are done, you actually can move with the new version that you want, or you can actually roll back. So I think this kind of what it allows to have this blue-green type of deployments. And as I said, we handle this with views. So it hides or shows the different columns. Is like, for example, here we are transforming full name to first name and last name. And as you can see here, there is like this constraint, new age, not null, new age, last name. So we actually transform everything while we are doing this migration. Both actually views are available through different schema versions. And this is for people who is wondering how to do this change. If you are used to Postgres, we do this with search path. It's pretty simple. And we have this automatic backfilling, as I said. We have this up and down expressions. So we are converting the data. We can actually also control the size. And because when you're modifying, you still don't want to take long running locks. So you try to make transactions as short as possible. So we can actually adjust this batching size. Yeah, this is, I think, the similar thing. It can go in both ways. And try log trick is built in. What does it mean? That we actually have the, let's say, when you set a log timeout, there might be a time that you will actually get affected by the set log timeout while you are waiting to acquire the log. And so we have this like retry logic included in the tool as well. Okay, and the clear benefits, I wanted to keep it short. Rollbacks is easy. I think this is something that people usually avoid doing it. They just keep roll forward, they call it. People are afraid of to roll back, and this actually makes it super easy. And it makes sure the things are safe, the migrations are safe, you don't cause any downtime that is you didn't want. And yeah, the merging workflow always works the same. You start the migration, you roll out the application upgrade, and then you complete the PG role migration. We added recently a very important subcommand. It's called convert, because many people wanted to use PG role integrated with their ORM workflows. So we get these SQL migrations that ORMs generate, and we convert them to PG role migrations. And this was something really wanted by the community. So I wanted to mention here, it was part of the last release we made 2 weeks ago. And if you would like to learn more, we have a website as well, pgrol.com. Then you can see documentation and blog posts that we keep writing, and you can access the repository here. I don't know if we have time, I could do a demo, but probably we don't have it, so I will skip it.